Hello everyone, welcome to part 5 of the video lecture on registers. So what we were discussing so far from part 1 to 4 is about registers, and we already seen how we can keep some information inside a register. We experimented, we tried to understand that concept with the help of the D flip-flop, but in general you can think of other flip-flops also, but D is something easy to visualize, okay? And register is what which can store information as well as it can move information if needed. Move basically the shift operation, right? So accordingly we are having the shift registers which can shift the data towards right or left, right? So accordingly we can enter data into the register in a serial manner or in a parallel manner. Similarly, you can take information from the register in a serial manner one after another, right, or in a parallel way. So accordingly we have 4 combinations of registers. The first category is something called serial in and serial out. So we are giving information to the register in a serial manner. Also we are taking output from the register in a serial way. So this is something we discussed in the part 4, I think. Then another category is serial in on itself, but parallel out. We can take information parallel. This is what we are going to discuss here. This all we already covered, I think. Then another category is parallel in and serial out. This we will explore in the next upcoming videos. And another one is parallel in and parallel out, right? This also we saw in the introduction video, because it is very easy to visualize. All D flip-flops, we are giving the data parallelly, right, simultaneously, and they are giving the output in the next clock cycle, say parallel simultaneously, right? There is nothing more interested on it. That is the one which is giving the basic working. Okay, so these 2 things we already explored, and this is what we are going to explore now, and this we will see in the next video. Yeah, that about it. So the topic of discussion is serial in and parallel out shift register. So what kind of shifting, why it is called a shift register? Because data is entered into the register in a serial manner, right? So whenever a first bit enter into first flip-flop, it is to be shifted right so that the second bit can enter. So that shift operation is there for taking the data, but for data to leave the register, we can do that parallelly we can take all the outputs of all the flip-flop, okay? So the basic concept, like if I need an n bit register, n flip-flops are needed, so that remains same here also. So data bits are entered serially. That is typically the least significant bit first, right? For example, if I want to enter the data, say 1100, and least significant 0 you enter, then the next 0, then 1 1, like that you can enter the data into the register. Then into a SIPO register in the same manner as SIPO. So this is something what we seen already in serial out. The same way we will apply here for entering the data. Now the difference is that the way in which the data bits are taken out of the register. In parallel output register, the output of each stage is available, and we can take everything simultaneously. Okay, so that is the way we are taking the data out, but we are inserting data in a serial manner. Okay, so once the data is stored, each bit is available in the respective output line, and all bits are available simultaneously also. So rather than on a bit by bit manner as with the serial output, here all the input we can take directly, because every flip-flop have its own output, right? So from that together you will get the whole thing. So this is a typical diagram of a 4-bit serial in parallel out register. Yes, that about it. So 4-bit serial in parallel out register, definitely as it is supposed to store 4 bits, right? So 4 flip-flops are needed, 4 free D flip-flop we are having, and the output of first D flip-flop we are connecting as input to the second one. So this is a serial connection, right? So that is how you are shifting the data from one to another. So the data will come like this. So whatever data you want to feed the circuit, you apply here, say 1 1 0 0. So first 0 you take to output of this, then the 0 will shift towards this. So like that finally this 0 will come. Somehow you pull this 0 towards the end by successive shift operation, and then this 0 you take here, and then this 1 you take here, and then this 1 you take here. So that is how you will load the data maybe after 4 clock cycle. Clock is something applied simultaneously to all the flip-flops. So that is a basic configuration we are having, right? So after say 4th clock cycle you will get the data in all the flip-flop. So now you know the data is taken out in a parallel way, right? So Q0, Q1, Q2, Q3, like that 4 bits you are taking out. Yes, so that about it. So it's clear, right? So if you are not taking out like this, if you are taking from here one after another, so then it will be serial in, serial out. Now here data is entered serially, but we are taking it parallelly. Yes, and we will see an example also, then if any doubt it will be clear. So this is a typical diagram, I mean the shorthand notation, right? The logical, the symbolic diagram of a this SRG means shift register 4 bit, if the 4 means 4, and data input is shown like this, but output is shown. So by that you have to understand that the data is coming in a serial manner, and data is coming out in a parallel manner. So this is understood, right? So from the diagram it is clear that it is a SIPO register. So that is not written explicitly, it is understood by default, it is so, right? So and clock also you are applying. So singular means you are applying to all the flip flops. So that is understood, that is default thing, right? Now let's see an example. Show the states of a 4-bit serial in parallel out register for the data input and clock given. So like that they can ask you any type of question. So you have to understand the basic working, and accordingly you can illustrate any example, right? So some clock is given and data input is also given, and you have to visualize or you have to illustrate the output of 4 flip-flops, like in every clock cycle what is happening, and finally whether you are getting this 0 1 1 0 as the output of 4 flip-flops simultaneously. So let's see. So this is the input you are having, and this is a clock you are having. So you know by default this notation means it is positive edge triggered, right? Positive edge or rising edge of the clock which is having a transition. So at this point this flip-flop will be triggered. I mean the first flip-flop will be triggered. You know, the output of the first flip-flop you are calling as Q0, right? This one, and second one you are calling as Q1, whatever it is. Anyway, now the data is available at Q0. So Q0 will project, I mean if you are checking that Q0, you will see the least significant bit of the original data. So for the original data, the least significant bit was actually 0, right? When the clock is activated, that time the input was 0. So that 0 will be directly reflected in the Q0 output, the first flip-flops output. And you know the initial state of the flip-flops, here we assumed that all flip-flops are initially 1, means we may executed that preset operation and we may done it. Or to initialize 0, you can start with any assumption, it is fine. But here you know we have a transition from high to low, maybe because of that in textbook or some material I referred, they started with a 1. You can start with any assumption, that you have to clearly write in your answer sheet, okay? So here Q0, Q1, Q2, Q3 all are in high active, I mean high initially. So it is initialized with 1 1 1 1. So whenever this clause is activated, you know only the first flip-flop will be executed, it will be triggered. I mean all others will be triggered, but only the first one is having a valid input right now, right? So this 0 so it's like normally if this is a least significant bit, this will be inserted first, but I think in this diagram they are inserting from the leftmost. So this Q0 then so this one will be available in Q0. Let's see that, okay? So anyway, that is a convention, whether you can start giving the input from left to right or right to left. So typically it is from right to left, so that we are expecting that we are going to get the same pattern. But anyway, this 0 1 1 0, it is looking like a palindrome in both directions, it looks same. But anyway, I think that also some kind of assumption we are having. So let's see so what they are doing. So Q0 is the output of the first flip-flop, that alone is getting 0, okay? So others are now in 1. Okay, so they are continuing their initial state, that is active high voltage, right? Now during the next clock cycle, what is happening? Again, always there will be a change for the first flip-flop, because first flip-flop is the one which is directly connected to the data input. So as the data input keep changing, the output of the first flip-flop will change. But for second, third and fourth one, so that they are depending on the first one, right? Second one depends on first one, third one depends on second one. So accordingly their output will change. Okay, so that about it. So if you are looking at Q0, you can see that it is exact copy of the input, like 0, then 1, 1, then 0, like that. And if you are looking at the Q1, that time you have to be careful. So Q1 initially it is 1. So whenever the clock is activated, you know what happened? The first flip-flop changed its input say to high, and that 1 is given as input to the second flip flop. So output of the first flip flop. So this diagram also you have to take parallel so that it will be very clear. The 0 I applied so that the first one is showing me a 0. Now I am applying the second bit is coming as the input, so that will be reflected. So before that both the flip flop will work simultaneously, right? So this 0 will come here and this 1 will come here like this. So Q0 will update to 1 where Q1 update to 0. Q1 was initially high, right? That initial high, now it changed to 0. But why Q0 is maintaining 1? Because Q0 get the second bit. Q1 is getting the first bit only. So that is now shifted to Q1. Okay, so or the flip flop corresponding to Q1. Now in the third clock cycle, see what will happen. This Q1 behavior is simply shifted towards Q2. So always what is Q1, that will be Q2 in the next clock cycle. Okay, and the Q0 behavior will shift to not this one, and the immediate previous clock. Immediate previous clock Q0, sorry, the Q1 behavior will shift to Q2. Okay, and why this Q2? So far, so you can't say like that, because if you are observing that Q2 is initially I said to 1, right? So that's 1, it is continuing. Right, now in the third clock cycle, so this is our first clock cycle, this is the second clock cycle. During second clock cycle, something is available in Q2. Okay, so see, okay, fine. So in the third clock cycle only the information from Q2 will be propagated to Q3. So that is the order. So let's see what happened. Q2 was 1, right, initially. So as soon as we are reaching the third clock cycle, and that time Q2 will be triggered. Previously also Q2 triggered, but there was no valid input to Q2, right? So that time it will simply maintain that 1, right? It was keeping that 1. So now Q2 input is actually Q1 output, and Q1 output was like low, and that low will reflect here. Okay, so before that you don't think like it is a previous, it was in 1, right? So in because we initialized every flip flop to 1, so that 1 is changed to 0 during the third clock cycle only, because this, which is this 0 is the first bit we inserted, right? So initially we inserted this 0, and this 0 is this particular 0. Let's focus this 0. Let me highlight this particular 0. This 0 initially I applied, so that now this is 0. Next time this 0 is actually shifted to this. Next time this same 0 is shifted to this. So this is the story. Okay, so this is how it is working. Now let's see what about the next bit. If you are looking at the bit 1 was initially at Q0. Only Q0 can change its output like that. I mean the second clock cycle. This is about the first clock cycle, and this is about the second clock cycle, right? And now see this Q0 updated to 1, and what about Q1? You don't think about it, because Q1 was initially 1, and during the second clock cycle this one reflected here like that, because this 0 is shifted to Q1 and the space is occupied by this one, something like that. Hope you are getting, right? Similarly in the third clock cycle you can see this 0 is shifted towards Q2. So till that Q2 was in active high. Okay, so whenever this one is shifted towards this, there is a space for it, so that the next bit will be shifted to this. So like that it will happen, and finally what is the conclusion here? Okay, so the conclusion is something like, we will see that this second bit, okay, so this I am highlighting like this one is initially in Q0, now in the next clock cycle. So we are just seeing the clock also here. During the third clock cycle this one will come here. Now in the fourth clock cycle this one will come here also. This is how this one is moving actually. Okay, so this is the first clock cycle, and the second clock cycle, third clock cycle, fourth clock cycle, like that this second bit is moving. Now what about the third bit? Third bit was your I'm just trying to see this one only, and that is updated to Q0 at this point, right? And the same will come here. Maybe in the next it will be shifted to the next flip flop, like that. Okay, so that about it. And now during the fourth clock cycle, what is going to happen? Similarly, this 0 will come here also. Okay, so just like this we are continuing. I explained up to that. 0 will come here also. And finally, in the fourth clock cycle, during a positive transition from the fourth clock cycle, and that time only this, I mean, now you are applying the last bit, that is again 0, and this Q0 will immediately show this 0. Now if you are applying more clock pulse, accordingly that shifting will keep going on, but what we need is after 4 clock cycle, now you are very clear that the information is completely fed into the flip-flop, so that the what we can see this the first bit you inserted is now reaching at Q3, and the last bit you inserted is now at Q0, right? So normally it is to be read like Q3, Q2, Q1, Q0, whatever it is. So that anyway, as you can see that in the last clock cycle we are getting the output for all the 4 flip-flop, right? So that is 0, 1, 1, 0. So that you are taking simultaneously or parallelly. Okay. So that is the idea. Anyway, so this is the notation, and you can see that the outputs are like Q0, Q1, Q2, Q3. And that is what you are getting like this. Okay, so hope it is clear. So the register contains 0, 1, 1, 0. You can see that 0, 1, 1, 0, right? But after 4 clock cycle only. After 4 clock cycle, if you are observing the register, you will see this pattern 0, 1, 1, 0. Yes. That about it. Hope it, I taken some more time for explaining this. Might be with the practice it will be very clear. So the simple thing only, this you have to understand, like this 0 is shifting here, this 0 like that. Similarly 1 is flowing like this. So that is the order, right? Anyways, hope it is clear. Thank you.